Pulleys and wedges, type 2, 2 strings, 2 tensions, horizontal. So in 2003 we were given a particle of mass 3 kilograms resting on a smooth horizontal table. So this time we have no friction with the table and it's attached by 2 inelastic strings. So again, inelastic, so therefore we've no bouncing with the 1 kg and the 6 kg, so no simple harmonic motion. And it's hanging over smooth pulleys, so again, no friction between the pulleys. So again, we're told the system is released from rest, and we have to find the acceleration of the system. And it's really important here, we can't put our answer in decimal, it must be in terms of g. So they're clearly specifying how they want their answer in this question. So if we look at the overall picture, we can see that we have the 6 kg acting down, so the weight is going to be 6g. We're going to have tension acting away in the strings. So again, 1 kg and 1g, and again tension acting away. But because we have 2 separate strings this time, we're going to have 2 different tensions. So I'm going to give T for one tension and S for the other. The 3 kg is also going to have weight acting down. So it's going to be mass times gravity. So again, remember weight is mass times gravity. So that's where we're getting these 3g, 1g and 6g from. But because it's in contact with the table, we're also going to have a reaction force. Now we would expect the 6 kg to pull the system downwards, which means the 1 kg will accelerate upwards and the 3 kg will accelerate to the right. Now we have to remember that the tension always acts away from the object. So because the strings are attached to the 3 kg, we're going to have tensions pulling on either side of this block. So again, we'll have S acting away and T acting away from the 3 kg. Okay, so now we have our overall big picture. We're going to take this picture apart and we're going to look at each individual particle and draw force diagrams acting on each particle so we can set up our simultaneous equations and then solve. So I'm going to start with the 3 kg mass. So the 3 kg has quite a lot going on here. So it's in contact with the surface. So we're going to have S acting away. We're going to have T acting in the opposite direction. We've no friction. So if we had friction, we'd have to take that into account as well. We have our reaction force and our weight. And it's going to accelerate to the right. Okay, so what we want to look at here then are our net forces. So I'm not interested in or being equal to 3g here because the block isn't lifting up or down because I don't have any friction. And the only reason I would write down or equals 3g is if I'm going to use it for F is equal to mu or. But because we've no friction here, I'm only interested in the horizontal motion. So in the horizontal motion, our net force can be calculated using F equals ma. And because it's accelerating to the right, our leading force will be the tension to the right minus the tension to the left, and that will be equal to the mass times acceleration. So in other words, S minus T will be equal to 3 times A. So this is our first equation. We're now going to repeat that for the other 2 particles. So I'm going to do the 1 kg next. So for the 1 kg, we only had 2 forces acting on it. We had tension pulling it up, and we have its weight pulling it down. And it was the lighter of the 2, so it's going to be pulled up. So it's accelerating in an upward direction. So again, the net forces in the vertical direction can be found by getting the difference between the tension and the weight. And that net force will be equal to mass times acceleration, where the weight is g, the mass is 1, and the acceleration is a. So I can say that the tension is equal to the acceleration plus gravity. So this is my second equation. So my third particle, so my third force diagram is going to be for the 6 kg. And the 6 kg, again, only has 2 forces acting on it. So the tension, making sure this time it's S, not T. And the weight of the particle, so gravity acting on it, will give it a downward force of 6g. And it's accelerating down this time. So again, only vertical motion. So therefore our net forces can be found by getting the difference between the weight and the tension. And because it's accelerating down, the leading force is the weight. So we say W minus S is equal to MA, where W is 6G, the mass is 6, and the acceleration is A. So again, if I get S in its own, that can be 6G minus 6A. So I now have 3 equations. So if I look at how I'm going to use these 3 equations, well, I have S minus T equals 3A. So that means I can put in for S and I can put in for T into equation 1, which means I will only then have A and G in my equation. And therefore that will allow me to get A, which is all I'm looking for in this question. I'm not interested in S or T. So what I'm going to do is I'm going to sub equation 2 and 3 into equation 1. So if I do that, I have S, which is 6G minus 6A, minus T, which is G plus A, and that's equal to 3A. So I have 6G minus 6A minus G minus A equals 3A. And if I bring all the A's to one side, I end up with 10A is equal to 5G, and therefore A is equal to 5G over 10, which is of course G over 2. So lovely little question that, but of course the nicer they are, the less the marks going for it. So it's only a 20 mark question, and we had 5 for getting our first equation, 5 for getting our second equation, 5 for getting our third equation, and 5 for getting the answer.